All right, let's work some examples using the slope-intercept form of a linear equation in two variables. And I've just reminded you here, when a linear equation in two variables is solved for y, meaning y is by itself on one side, we get slope-intercept form, which is y equals mx plus b. M is the slope, and the ordered pair 0, comma b is the y-intercept. Okay, so let's do our first example. Okay, so I have this linear equation in two variables that's already solved for y. So we know that the slope is what's multiplied by x, so that's the 4/3. And we know that the ordered pair 0, comma -7, because our b value is -7, is the y-intercept. So we know our slope and we know our y-intercept. So now we have to use that information to graph the line. It says determine the slope and y-intercept. We've done that. Then use that information to graph the line. So what we're going to do is start with this ordered pair, because it's easy to plot an ordered pair. 0, -7 would be down here, of course. And then I have to somehow use my slope. Well, I'm going to use a rise of 4 with a run of 3. So from this point on the line, I can rise 1, 2, 3, 4, and run 1, 2, 3. And that gives me another point on the line. And really, I only need those 2 points and I could graph the line, but to get a better, more precise line, I'll use my slope again. So from there, I'll rise 1, 2, 3, 4, and I'll run 1, 2, 3 as well, and get another point. And I can keep repeating this procedure. 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3. Sorry, sound like I'm making some kind of workout video or something. And so we get all these points, and in fact, we can go left 3 and down 4. 1, 2, 3, 1, 2, 3, 4 to continue the pattern. That would be like a run of -3 and a rise of -4, which still is a positive 4/3 when you divide to get your slope. So here is the line, and you can see how easy it made connecting those points to be since I had so many. Notice I'm putting arrows at the end because this line goes forever in both directions. Let's try another example. In this example, we get a linear equation in two variables, x and y, but we're told to write it in slope-intercept form. You notice this is not solved for y, so we have to do that. And then once we do that, we can graph the line. So we'll start by solving for y. We need y by itself. So let me recopy the equation. I need y by itself, so I'm going to subtract my 2x from both sides first. So I get -5y equals 10 minus 2x. Now, I'm going to actually avoid writing it that way, and instead, I'm going to write -5y, and I'll put my x term first, my -2x term first, and my +10 term second, so that it looks like mx plus b, right? A number times x plus a number here. And it does now. Finally, I'll divide both sides by -5 to get y completely by itself. And that's going to give me y on the left. And on the right, I have to divide my -2 by my -5. Well, that gives me a positive because a negative divided by a negative is positive, and it gives me +2/5 x. Then I need to divide my +10 by my -5. That's going to give me 10 divided by -5 is -2. So that is the slope-intercept form. Now we can do something with it. This first equation wasn't too useful. I can't look at that equation and know the slope, for example, but I can here. I know that the slope is 2/5 and the y-intercept is the ordered pair 0, -2. So I can plot my y-intercept 0, -2, and I can rise 2 and run 5. So up 2 over 5, up 2 over 5. And so I've got 2 points in that direction. If I want more, let's go to the left. I'll go left 5 and down 2. Left 5 and down 2. and I've got 2 more points. So now I simply need to draw my line. So we had to solve for y to get slope-intercept form. Once we did that, we knew the slope and the y-intercept, and then we could use that information to graph the line. Okay, let's do one more example. In this example, we have the equations of 2 lines. Line 1, I've written L sub 1, and line 2, I've written L sub 2. So I've got 2 different equations, 2 different lines, and the instructions tell us to determine if they're parallel, perpendicular, or neither. So the first thing I want to remind you is that 2 lines are parallel if they have equal slopes. So if their slopes are exactly the same, the lines are parallel. 2 lines are perpendicular if they have opposite reciprocal slopes. So they have to have opposite signs, positive or negative, and they have to be reciprocals of each other. Okay? So it's important to know that, of course, before we can do that problem. So what this boils down to is I need to know the slopes. So we need the slopes of both lines so that we can compare. So I go up here and I ask myself, do I know the slopes of these 2 lines? Well, the first line, this equation is in slope-intercept form. So I can tell that my slope right away is 1/3. So let's call that slope 1, m sub 1. Okay? So I know slope 1 or m sub 1 is 1/3. However, this is not in slope-intercept form. So let's write the equation for line 2 in slope-intercept form. So let me recopy it down here. And to get it in slope-intercept form, I need to solve for y. So in this case, to solve for y, I just subtract 3x from both sides. So on the left side, I have y, and on the right side, remember, I'm going to put my x term, negative 3x first, and then my constant term, positive 9 second. And now it is solved for y, and I can tell, now that this is in slope-intercept form, I can tell that the slope of line 2, so slope 2, equals negative 3. Well, m2 equals negative 3 and m1 equals positive 1/3. They are opposites because one's negative, one's positive, and 3 and 1/3 are reciprocals. So we can finally answer the question. The lines are perpendicular because their slopes are opposite reciprocals. So you can start to see you can do lots of things with this slope-intercept form of a linear equation in 2 variables. And I'm not saying I gave you every possible example that you could ever see here, but hopefully I gave you a variety so you can see how to use this to do different things and solve other types of problems.